In the 8 problems we did on page 600, what we found from U substitution was that when we found the derivative of that inside function, it gave us enough pieces that were outside of that complex function that we were able to successfully translate the complicated function in terms of x in terms of a not very complicated function in terms of u. We needed to fuss around with constant multiples from time to time, but beyond that, there wasn't any problem at all. In the example on page 601, we're going to see a case where we're not so lucky. And as I said at the end of the last video, as far as I know, the AP is never going to ask you to do something like this. As a calculus student, I was never asked to do anything like this, but I will expose it to you just because it's a page in the notes. And so let's take a look at how you can find a slightly larger case of functions you can solve by using this expanded notion of U substitution. All right, so here we're going to try to find the indefinite integral of x times 2x minus 1 cubed dx. All right, in this case, we really could solve this just by multiplying out 2x minus 1 3 times and then, multiplying that by x. It's going to give us a polynomial, and we can just use the power rule for that. But let's take a look at this the way that the author of these notes wanted you to take care of this. All right, so I'm not going to tackle this first bunch of problems. This first bunch of questions is just basically saying what we did on the last page is not going to work for us. And so let's let u be our inner function. So u is equal to 2x minus 1. All right, and now we've got du, which is equal to 2 times dx. And I don't have a 2 here outside of this complicated function. So we're going to have to do the same thing we did in the last page, which is say 1/2 times du is equal to dx. All right. So why don't I come over here and write down what we've got so far? So we've got, I'm going to give myself some room here. I've got the indefinite integral. So 2x minus 1 cubed is going to become u cubed. That's pretty. Dx, I can write as 1/2 times du. And then I've got the x here. So expressing this x over here is something that I can't do because I don't know what x is. I don't know what to replace x with in terms of u, given what I've got right here. All right. So what we're going to do is we're going to take this extra box down here. Since we already know that u is equal to 2x minus 1, I can solve this for x and then figure out how to substitute this in for our integral. All right, so what does it take to get x alone on its side of the equation? Well, I'll start out by adding 1 to both sides of the equation. So 2x is equal to u plus 1. And then I'll divide both sides by 2. So x is equal to 1/2 times u plus 1. Okay? So let's see what we get over here. So substituting now, I can substitute in for x. X is equal to 1/2 times u plus 1 times u cubed times 1/2 du. And now that I did this extra little bit of algebra work, I now have this integral in terms of x in terms of an integral instead of in terms of u. Not 100% sure this is clearer than what we had before, but let's take a stab at it. First thing is I've got this constant term of 1/2 and this constant multiple of 1/2 over here. So let's pull both of those outside of the integral. So that's 1/4 times the integral of u plus 1 times u cubed du. All right, so now I can use the distributive property here. So that's going to become u to the 4th plus u cubed du. Oh, hey, this is clearer than what we had before. All right, so I can find an indefinite integral of this, because this is just a polynomial in terms of u. So this is 1/4 times, what's the antiderivative of u to the 4th? 1/5 u to the 5th. The antiderivative of u cubed is 1/4 times u to the 4th. And then I want to add a constant to all of that. And why don't I use the distributive rule again to have this be just a single polynomial? So this is going to be 1/20, and then u to the 5th, I'm going to substitute x back in. So this is going to be 2x minus 1 to the 5th power plus 1/4 times 1/4 is 1/16 times u to the 4th power, which is 2x minus 1 to the 4th power, plus some constant. So we were able to find the indefinite integral of this by doing this slightly more complicated version of u substitution, where we weren't just solving for u, we weren't just solving for dx, but we also needed to solve for x itself in this case in order to come up to this point. And as I mentioned before, if you just multiplied out 2x minus 1 times 2x minus 1 times 2x minus 1 and multiplied that polynomial by x and then took the indefinite integral of that, I have a feeling that that would be prettier than what we just did. I don't want to dish on this too much, but I will say once again that this is a level of u substitution that you will not be tested on by the AP exam. And I have not seen a calculus course. I have not sat for a calculus course that would ask you to do that. But that's an exposure to it. So the two problems that are in the homework set that have you doing problems like this, obviously, I don't expect you to do them. But if you do want to practice with them, go nuts on it. All right, so that's all we have to talk about as far as u substitution goes. If you can do those problems on page 200, then that is an awesome example of broadening your ability to take antiderivatives.